Greeting to you all. I'm going to cover signals and system practicals. As you go through the syllabus, so there are the total 8 practicals referred. These are generate and plot basic elementary signal, write the codes to plot the sinusoidal signals with different phase angle, develop codes to simulate and plot an exponential signal, verify sampling theorem, generate real-time speech signal and do the spectral analysis, generate real-time music signal and do the spectral analysis, verify convolution operation, verify trigonometric Fourier series and Gibbs phenomenon. So the practical in the signals and system are very important because in the world we are dealing with signals and system. So like the speech signal is very important signal, so which generate so most of the message which are related with your body, and most of the time we are working only on the speech signal. Like thousands of speech signals are available in the world, and if you can able to do analysis of the signal, so like it is like that is a analysis of the patient, and accordingly doctor identify the particular disease based on the signal which is receiving from the patient. Like from the signal we can able to analysis anything because it conveys all the information, and all these signals can be generated by using any software. Here we are going to use MATLAB. You can generate these signals using MATLAB. You can generate using C, C++, Python, or any other appropriate language. There is no restriction of using a particular language. And I'm going to use MATLAB, which means for matrix laboratory. Most of the task, whatever it may be signal, it may be image, it is considered as a matrix, and you can perform various operations in the matrix. So this is developed by the mathematician. So this all signal or the image are considered as it is a set of matrix, and just if you can able to generate this matrix, or you know different operations of the matrix, then you can able to understand this MATLAB very well. And there are a number of toolboxes are available when you want to perform operations using particular toolbox. Then those functions are included in those toolbox. If I want to use signal processing operation, those are available in signal processing. Then if you want to use machine learning, so there are the related to machine learning toolbox are available, deep learning, wavelet toolbox, control system toolbox. So it is like a C. If we want to perform operations uh, in a particular area, so particular toolbox can be used. We are going to use here signal processing toolbox. So learning this MATLAB is learning new language. So when you want to learn new language, so there are some commonly used words are there for any constructing any sentence. So those commonly words are there. So like for writing particular program, so there are some commonly used built-in functions are there. If you become familiar with mostly 60 to 70% the functions, commonly used functions are there, and these commonly used functions are listed here. So first one is a CLC, that is a clear the screen, and if you write semicolon, you should write semicolon after every statement. If you write semicolon, it indicates you are suppressing the result, otherwise the result are displayed in the command window. And after every statement, if required, you need to write the percentage sign that indicates whatever you are writing in front of percentage sign, that is a clear that is comment. So like CLC is used for the clear screen. Clear all, the function is used for clear all the workspace variable. Then close all is used to close all the windows which are opened in MATLAB. Plot and subplot are very important command which are used to plot the figure, and subplot is used to divide the figure into number of sub windows. Then the stem is used to plot the discrete signal. Title is used to give the title to the figure. X label is used to give the X label to the figure. Y label is used to give Y label to the figure. Help is again the important function. So if you write any function in front of help, so all the syntax along with the example are displayed in the command window, and you can learn that particular function and you can use in your program. Then the sum in this particular program to generate different basic elementary signal, we're going to use these functions. Like first one is a zeros. As I told you, the MATLAB, So everything is considered as a matrix. So whatever you want to generate, so mostly you should generate in the form of matrix. So first is a zeros. So zeros is used to generate the matrix, and in bracket whatever you're writing, the first number is considered as a number of rows, second number is considered as a number of zeros. Here in this example, zeros 1 comma 10, the one row and the 10 elements are generated, that is a 10 zeros are generated in a single row. If you write 2 comma 10, the two row and the 10 element each row, all zeros are generated. So accordingly we can generate zeros. Similarly we can generate ones, that is a one row 10 ones will be generated using ones command. Then the exp is directly it is used to generate the exponential signal. So a is the rate of decay or the rate of growing, and the t is your the time series vector. Sync is used to generate the sync function. Then the rect plus is used to generate a rectangular function. So directly you can use this function, and the commonly used the function are used, and with the help of these important functions and commonly used functions, you can able to write a program to generate different basic elementary signal. As you know, basic elementary signals are very important, and any signal can be reconstructed using basic elementary signals. Now, the first experiment, as mentioned in the syllabus, is to generate and plot falling signals in time domain. That is impulse function, unit step, exponential, unit ramp, sync, and rectangular we want to generate it. Now, first I have written the program impulse function. So, this first I will explain the code, then I will move on to the MATLAB. And before going to this code, I wanted to tell you about the impulse function mathematically, how it is represented. So it is represented mathematically like the integration minus infinity to infinity del of dt is equal to 1 for the t is equal to 0, and dt is equal to del of t is equal to 0 for t is not equal to 0. It indicates that this function present only for t is equal to 0, and for all other values its value is 0. If you want to plot, you want to generate, that is the x-axis and the y-axis. X-axis is called as a time series vector, and the y-axis is called as the amplitude for all the respective values of the t. So accordingly, this is your continuous time impulse function, and the discrete time impulse function mathematically represented as a del of n is equal to 1 for n is equal to 0, and is equal to 0 for n is not equal to 0. So for n is equal to 0, its value is 1 and its value is 0 for n is not equal to 0. In the form of matrix, this del function can be represented as a 1. So arrow indicates the value of that particular sample for n is equal to 0. And here before this n is equal to 0, all values are 0. After n is equal to 0, all values are zeros. So whatever number of zeros and the ones you want to generate, so you can generate with the help of zeros and ones, and this particular matrix can be formed, and you can generate the time series vector and this your the amplitude, and you can plot against one another. Now let us try to understand about the code, then we'll move to the MATLAB directly. So this is for the impulse function, as I told you. So CLC, clear all, and the close all are the commonly used, and you have to use for writing any program. First you should write these three functions. CLC used to clear the screen, clear all workspace variable, close all the open windows. Then this is a time series vector. So the very important function which is used many times to generate time series vector, as I told you. So we need x-axis and the y-axis. So this is the x-axis values. So I want to generate the values of the time from minus 10 to 10. So you can generate minus 100 to 100, minus 50 to 50, or the any values you want to generate. So minus 10 colon 1 colon 10. So that indicates I want to generate the time series vector between minus 10 to 10 with the spacing of 1. So you can generate now, so total there are the 21 time series values are generated, that is from the minus 10 to 10. So then these 21 values I want to generate in the particular matrix. So that is your the y-axis. So y is equal to now the zeros 1 comma 10. So the 10 zeros, then ones 1 comma 1. So only one is generated in the matrix as I have shown you. Then the zeros 1 comma 10. So 10 zeros, 1 ones, and the 10 zeros. So this vector or the matrix I have generated. Now I want to plot against this t comma y. So directly there is a stem command is used, which is used to plot the discrete signal. You can plot the same signal in the continuous time domain by using the plot. So stem first you should give the x-axis, then you should give y axis. Now our x-axis is the time series vector. Now y-axis is this is generated in the matrix, that is y. Then all these three title, x label and the y label, are the common. As I explained you can give the title for the figure like the here unit impulse function, then the x label as a time, y label as a time, and if you write percentage sign, so that percentage sign is used to indicate the comment for any that is an unknown person. So the you have written the program, he also should know the aim of the program or what that particular statement indicates, then he can also learn. So mostly all the statements should be preceded by the percentage sign and the comment, so that the unknown person can also understand the task of the particular program. So this is only for important command is that is a T and the Y. Only these two are the important, other are commonly used as I told you. So writing a program in the MATLAB is a very easy task. Now let us move to the MATLAB. So everyone know about the MATLAB indicates matrix laboratory. There are the only 5 windows are used. One is called as the command window, which is very important window. Here the two, that is a command prompt, is displayed. Whatever command you want to execute or the function, you write that function and enter, so it will be executed and the result are displayed there. And if you write the particular program and after executing program, all the results are also displayed in the command window. The next in window is the editor window. So whatever new program you want to create, you need to create in the editor window, and there is a run command, and by pressing that run command, so this editor window, whatever you are writing, that program get executed and its results are displayed in the command prompt or the different window if you have generated using the stem or the plot or the subplot. So those are opened in the separate window, that is called as a figure window. Next, another important variable is called as a workspace variable. So whatever program here you are writing and what variable you are using, so those variable along with the dimensions are displayed in the workspace variables that you will come to know. The next is a current folder, in which folder you have stored the program, and what are the different programs which are stored in the current folder, all are displayed here. So accordingly, by pressing particular the file, so that particular file can be opened. So this is 4 window, and fifth window is called as a figure window, and after executing that plot or the stem, so the figure window will be created. So what program I have explained, the same program is written here. I have saved that program as a p1.m. So all these files or the programs called as a script file, so they should be, that is a saved as a .m extension. So after saving directly, it will be saved as a .m extension, and these are called as a m files. Now I want to execute this program. There is a run. So you press the run command. You see it will show the BG here. So the BG indicates it is executing now. It has executed the program, and this particular figure window is created. And if you look at the figure, so this is the impulse function. So this is just matrix. So 10 zeros, then 1 1, and the 10 zeros are there. Here the x-axis is the time, y-axis is the amplitude, and the name of the figure is unit impulse function. So just by using function title, x label and y label, you can change the x-axis, y-axis, and the title of the your figures. So this is like your the impulse function. So as I told you here, the important command used are once. So if you write in the command prompt, so 1 means 1 row, and the 10 ones I want to generate, and if you press here, so you see in the command windows, so 10 ones are generated, that is a 1 row. Or if you write once, that is suppose for example 3 comma 10, so that indicates the 3 rows and 10 ones. You see, like similarly zeros, here you can write it is 3 comma, suppose that is I will write 6. So 3 rows and 6 zeros in the each row are displayed here. So there is zeros, 3 comma 6. So you can see here. So 2 comma 6, 2 rows and the 6 zeros. Now I want to generate uh, the impulse function. So there should be only one. So accordingly, I can use any variable y, or you can use the any other variable, for example d. So is equal to, here the square bracket you should use, and zeros 1 comma, suppose I am using the 5 zeros, then only one should be there, once 1 comma 1. Then same you can use zeros again, the 1 comma 5, then bracket close, then bracket you see, and this only you have to plot. So like, and if you, I want to clear all this, there is a command window, you should write clc, there is a clear screen, and you see in the workspace variable, so there are some variable are created after executing this program, and you use here clear all. See here the answer d, t, y are the workspace variable. So if I write clear all, so this all workspace variable will get cleared. And now here this figure window is created. Now I want to clear this figure window previously generated. You can use close all, and you see after closing all, so the figure window will disappear. And again, if I want to clear this, you can use the clc, clear screen. So this is the program for the impulse function. So writing a code is very simple, but you should know the mathematical interpretation of that particular basic elementary signal. If you know those mathematical signal, and you can generate in the form of matrix using MATLAB. So this is very simple code. So similarly, we'll move on to the next program, that is a unit step function. So everyone know about again the unit step function. So I will again explain you what is unit step. So the mathematical representation of this unit step function is, I will show you on the screen, like it is represented using like u of t. Okay, u of t is equal to 1 for t is greater than or equal to 0, and this is equal to 0 for t is less than 0. It means graphically this signal can be represented. This is t and this is u of t, and all values are 1 for the t is greater than or equal to 0, and this is t is equal to 0, and here the values of this u of t are 0 for t is less than 0, and a discrete time signal can be represented as u of n is equal to 1 for n is greater than or equal to 0, is equal to 0 for n is less than 0, and this unit step function n. And graphically, if you want to plot, so the plot you can see like this. So this is for n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3, and the so on. And this is your u of n. Now we want to plot this. So this is your the time series vector. Whatever values you want to generate, you can generate. And this is your the y-axis. So amplitude vector you can be generated in any of the variable, and you can plot against one another. So this is like simple. You can make use of ones and zeros. And let us see the program for the unit step. As I told you again, you should write CLC, clear all, and close all for starting of the any program. Then here I have used in the different way, that how many number of your the time series vector you can generate. So that you can also take from the that inbuilt function input, n is equal to input, enter the values of n. Otherwise directly also you can take. Here I am writing n is equal to input, enter the value of n. You can then the command prompt will ask enter the values of n. If you enter, that will save in the n variable. Now, so that variable I want to generate here, I want to generate from the that is 0 to n minus 1. If I take 100 n, then 100 minus 1 is a 99. So 0 to 99, 100 time series vectors are generated. So directly you can write t is equal to 0, t is equal to 0 colon 1 colon 100, t is equal to 0 colon 1 colon 10. So anything you can also write. Here only I have shown input function is used to enter the values. So you can use or write program in different ways. Then I want all ones, because in the this is nothing but again the matrix. So which all the values are 1 for the n is greater than or equal to zeros. So I am writing ones 1 comma n. So 1 is number of rows and n is your the number of columns. So here the n number of elements are there is created which all values are 1. Then generally sometimes figure is used if there are the many figure. If you want to develop or generate separate figure window, you write the figure, then you write the this plot or the stem command. So by writing stem command, here t is your the x-axis, y is your y-axis. Then this your whatever vector you have generated in the t and the y are the plotted against one another. Then title, figure, and the your the x-axis are same. So now let us move on. Or here, when suppose you write in the write this particular function, you can copy and if now only there is one program I have generated. I want to again create another, that there is a editor window. So here you can save this program, just copy, and if you want to write here, so you write clc, then clear all, close all. So this is the program, and all other things, once again I will show you that if I want to generate the matrix all once, so you can use the suppose g is equal to ones comma 1 comma 10. So this is all tens. So this only I want to plot, and if you use clc, it is clear the command window, then clear all the workspace variable. Here in the workspace variable there is a g variable is created, so all workspace variable are cleared. Again I will write the clc, and now I will execute this command. So you can see the unit step function. Sorry, here I have not saved. Here I will save this as in a p2. You see directly p2.m file will be saved, and now this program will be executed. I will again press. See, enter the values of m. I want to enter, suppose for example 100, or if I want to enter the 50, or I suppose I will enter the 20 values. So just you enter 20 values. So you can see the variable created in the workspace are n, t, and y. So here the two times the program is I have pressed run, so therefore it is asking two time. Only one time I have to press. So now this mm, program is executed, and this unit step function is plotted. Here no x label, y label is written. So just again okay, it was previous I have used the plot. See, this is a unit step functions. So all values are 1 from the 0 to 20, and I think here the x label and the y label are not written. So here the figure stem, figure plot also written, so there is no need to write this. Here see, you write x label. What is x label here? That is amplitude. Y label I will write it as a time. Okay, so then again you see I will execute, enter the values. I will write here the 15. So enter, you see the here the 15 values are created from 0 to 14. I have written wrong, that is x-axis should be time and y-axis should be amplitude. So again I will again change. Here see x label is written amplitude, it should be time, so you can change. This is the time, and here it is again amplitude. Then again execute, automatically it will be saved. It will ask values. Now I will enter 20. So this your unit step function is generated. If you use stem, it is generated like this. If you use plot, it will generate the continuous time signal. So writing code is very easy, no need to close. So directly if you use close all the figures are automatically closed. And again I will use clc. Now this is about the unit step function. The next function, see, like this, what I have generated here, the result is also shown here how it is generated. Next is exponential. So this exponential function is also very easy. So before moving to exponential signal, I will just explain you the mathematical representation of this. Mathematically, all of you know that how the exponential signal is represented as like x of t is equal to e raised to minus at, and here it is u of t, for example. So here u of t indicates its value is present for 0 onwards. So this is t and this is x of t, and if it is a minus a, it is a decaying signal, and if it is plus a, it will be the growing signal. So whatever values you want to generate, you can take rate of decay, generate the time series vector, and for the exponential there is a exp function is there, and all time series vector generating title, x label, y label are same, CLC, close all, and the clear all are same. Only you need to use that exp function, then exponential signal can be generated. Now let us see this exponential function. First I will explain you the code. Similarly, CLC close or clear all, and here you generate the t is equal to 0 to 0 colon n. Here the same, I have used 0 colon 1 colon n in the previous case. So if you write 1, the spacing will be 1, and if suppose you want to change the spacing, there you can change 0 colon 2 colon 100. So it will generate vector from 0 to 100 with spacing of 2. But if you want to generate 1 by default, so this can be used also. T is equal to 0 colon n, it will generate number of vectors between 0 to n with a spacing of 1. Then here you can use input function, or even there is no need to use the input function. If you use input, enter the values of a, you can take it as a positive or the negative. Accordingly, growing or the decaying exponential signal will be generated. Then this is your the amplitude vector exp function is used to generate exponential signal a into t. Then exponential value are generated in the y, and the time series vector you plot against each other. Separate figure window is created, then the stem t comma y, or you can use plot t comma y. Title, figure, and the x label, y label are the common. Now this is a program for the exponential function. Now let us move to the program. I will copy here. Here you can copy anything, then you can open the edit window, you can save in the edit window. So this is the new editor window will be created. Then I will save this. You give the name file for this like the p1, automatically it will be saved as a p3.m. CLC close all, the clear all, then the time series vector you give the colon, or directly you can use 0 to 100, anything. A is equal to input, enter the values. So then exponential function, figure, stem, t comma y, the title, unit exponential, and here the I will show you later on the continuous exponential function, then x label as a time, y label as amplitude, okay. Then you run the program. It is asking values, so there is some error. So unrecognized function of the variable as a n, okay. See n here I have not specified, so therefore you can use here like the n is equal to input, then enter value of n, okay. Then again I will run this program. You check, enter the values of n. If suppose I want to generate there is a 20 values, it will ask values of a. If I want decaying signal, if suppose it is a minus 2 is there, I will enter. So these all variables are created. So this the particular exponential signal is generated. So if you take more values of your the n, we will see the plot here, and here amplitude you can take it anything. For again I will just change e is equal to suppose for example 10, it will start. Then I will run this program again. So enter the values of n. N is equal to, here I will take 100. Enter the values of a. I will take it as a -2, or suppose I will take a -1. You see how the plot is generated. So this is, I think, growing exponential signal. So again I will just change for your understanding. Again I will run. Enter the values of n. I will take values of n as a 20. Then enter the values of a is a -0.1. You see, this is how the exponential signal is plotted. It is a decaying. And if you similarly, if suppose I want to plot continuous time signal, you just plot. Already variables are created. I will use t comma y, and you just plot it. You see it is a decaying exponential signal which is generated. So like you change values of a and values of this t, you can plot various plot, and you can study how the different plots are generated using MATLAB. So this is about the exponential. Then this is how it is plotted. The next is your the ramp function. So everyone know about the ramp function. So ramp, here it is a unit ramp. So in case of the unit ramp, so the you can again uh, this signal is represented as a r of t is equal to t for t is greater than or equal to 0, and is equal to 0 for t is less than zeros. And accordingly, if you see the graphical representation t comma your r of t, so it will be generated like this. It means its slope is 1, so it is called as a unit. If t is equal to 1, its amplitude is 1. T is equal to 2, its amplitude is equal to 2. So you need to generate the vector that is of the amplitude. For example, r is equal to like the 1, 2, 3, 4, and the so on. And even the time series vector also should be equal to 1. From the 0 you can start 1, 2, 3, 4, and the so on. So this by using the time series vector, and you can use the both time series vector and you can plot against each other. So discrete as well as the continuous ramp signal can be generated. So now let us look at the code of this. Like the CLC, close or clear all are same. Then you can either use n or do not use, does not matter. Input enter the values of n, or directly you can take n. Then the t is equal to 0 to n, time series vector is generated. Then y is equal to here 0 to n. So therefore n number of vectors are generated, and here you should start with 1. Y is equal to 1 colon 1 colon n minus 1. So 1 2 between n minus 1. So this with spacing of 1, this your the amplitude vector is generated, and all other things are the common things. So now again, now let us move to MATLAB. See, you can make changes. You can write the code and you can check. So how it will look, it is P3. Now I will write press this one, CLC close all, and here you can take n is equal to enter the values of n, t is equal to 0 to n with spacing of n, time vector is generated, y is equal to 1 colon 1 n minus 1, so that amplitude vector is generated. Figure, new figure window is created, stem, title, here both are generated. So again you write x label, that is time, y label, amplitude. Then this is untitled, so first save it. I will save it as a p4. It is a m file, so it is saved. Now you run the program. Here enter the values of n. So value of n I want to enter as, for example, 20. There is error, so let us look at the error. There is a stem, x must be the same length. So here it should be, and x and y should be of the same length, then only it will be plotted. Here I have not used clear all, so therefore workspace variable are not cleared. I will use clear all, then I will run the program, enter the values of n. I will use the, again there is x must be of the same length. So what is, sorry, t and y I am using the stem t comma y. T is equal to 0 if it is 20. So this is a discrete time unit ramp function. That if you want to plot the continuous time, you use plot t comma y, and just to look at the figure. So this is your unit ramp functions. So accordingly you can generate different plots. Now the next one is your the sync function. So here only just you need to change this sync function should be used. All other things are the same. Now just I will again will show, I will execute this command. No need to explain this one. So I will generate again another open separate window in the editor window. So I will save this as a, for example, 5 P5. So P5 is saved. So this is, for example, this is T. Here the colon, just and here I use a subplot. Subplot indicates same figure window is divided into more than one windows. Or only just I will show you. I'm not going to use this subplot. X vector, y vector. So again, all other things are same. Only one or two functions are different. CLC, clear all, close all. So these are common. T, X, plot T comma X. Title, X label, that is time. Y label is amplitude. Okay, then I will save. I have saved this program. See, I will run this program. You see how the sync function will look like this. You see the mathematical representation. Accordingly, you can interpret. Now the next one is about the rectangular functions. So this is also same here in the rectangular function. So rect plus is used. Generate the square wave, and t is width of the pulse that we have seen. And you can decide the width of the pulse as a 0.2. That is the width of the rectangular pulse in the second can be taken. And you can generate the time series vector, and all other things are same. So again this I will show you. I will just copy this program. I will go, then I will open the editor window. I will save as a P6. Save this program. Now go to the program. All first it should be CLC. Then here I will make a habit of writing CLC, clear all, and close all. These three statements for before writing any program. Then that here sampling frequency you can take, or directly you can generate the time series vector, does not matter. Here I have taken fs is equal to 500, and 1 upon 500 is equal to 0.02. The spacing between minus 0.5 to 0.5 with a spacing of 0.2, these number of the vectors are generated. That you can decide. And the time here, the width of the pulse is taken as a 0.2. You can take any width of the pulse, and here directly function rect pulse is there. Again, the plot, title, x label, and the y label are same. Now you just run the program. There is error in the column, the invalid text character. Column number, text character. So this is a rectangular pulse, what we have studied. So its spacing between vector here is the 0.1. So 1 upon fs. So that you can change the values accordingly. You can generate. Here suppose I change here the width of the pulse as a, for example, the 0.3 second. You make change, then see. So accordingly your rectangular pulse is generated. So this is about the rectangular pulse. Here this is generated in the figure windows. Exponential I have shown you. So this is all about your practical number 1. So you can also try for more number of basic elementary signal direct functions are there. So thank you very much. Now next time we'll go for the second experiment in the signal and system. Thank you all. Enjoy your day.